Okay, another situation. Let's take a look at the inequality, the absolute value of x plus 2 greater than 3. So if you look at the question mark, so we know that all the values inside that absolute value have to be greater than 3. So you think about this. Is 3 greater than 3? And the answer is no. How about 4? Is 4 greater than 3? That answer would be yes. So we can instinctively tell that any of the values to the right of 3 on this number line are going to be greater than 3. All right. Now looking at the absolute value of negative 3, we know the absolute value of negative 3 is 3. Well, is 3 greater than 3? No. But how about negative 4? How about negative 3.1? The absolute value of negative 3.1 is positive 3.1. Is that greater than 3? The answer would be yes. So we know that all the values that are going to be the absolute values of less than negative 3 are going to be greater than positive 3. So we would actually write two statements here. We would go x plus 2 is greater than 3, or x plus 2 is less than negative 3. And now we would write, or we would solve for those two inequalities. So in this particular case, I would subtract 2 from both sides of this inequality, and I would get x is less than negative 5, or here I would get, if I subtract 2 from both sides of this inequality, I would get x is greater than 1. So this is basically going to be our solution for this particular inequality then. X is greater than 1 or x is less than negative 5. All right, and the way we would show that on the graph, you draw a graph here. And here is 1, 2, 3, 4, 5. Here's negative 5. So you draw a circle around negative 5 with darkening the number line going to the right. Here we have 1. Put a circle, and the circle tells you that that the solution, the number line, goes all the way up to the value but doesn't include the value itself. Okay, so this would be the graph for the solution to that inequality. All right. Now, one last thing about inequalities that you need to keep in mind, and this might be worth writing down. Okay, so whenever you multiply or divide an inequality by a negative number, the result is a reversing of the inequality symbol. Let's just take an inequality we know to be true. Let's say 4 is less than 5. Okay, we know that's true. 4 is less than 5. All right, if I were to multiply both sides of the inequality by negative 1. So now I have negative 4 and negative 5. Well, is negative 4 less than negative 5? No, it's greater than. It's greater than. So in order for the statement to remain true, in order for the inequality statement statement to remain true the inequality symbol must be reversed if inequality is multiplied or divided by a negative number. Okay. All right, let's try a couple more examples. Let's try this equation. Let's say I had 12 less than or equal to the absolute value of negative 5x minus 1. Okay? So this is going to create two statements. I'm going to have 12 is less than or equal to negative 5x minus 1. I'm also going to have negative 12 is greater than or equal to negative 5x minus 1. Okay, so I have two inequality statements that are derived from this one with an absolute value. Okay, so let's go ahead and work that. So first thing I'm going to do is I'm going to add 1 to both sides of the inequality. So now I have 13 is less than or equal to negative 5x. And here if I add 1 to both sides of the inequality, I get negative 11 is greater than or equal to negative 5x. Now the next step, in order to isolate x, I'm going to divide by negative 5. And what I do to one side of the inequality, I do to the other. Now, dividing by a negative number causes the inequality sign to be reversed. So now I have negative 13 fifths is greater than or equal to x. Here, a negative divided by a negative is a positive, so I have 11 fifths. 11 fifths is less than or equal to x. Okay? So, if I look at this, x is greater than, equal to 11 fifths. By the way, 11 fifths would be what? That'd be 2 1/5. We could also write that as x being greater than or equal to 2 1/5. Here I have, this is negative 2 3/5 greater than or equal to x, and I could write this as x is less than or equal to negative 2 3/5. So there's your statements, and the graph of that, would be, here is 2 1/5, and so all the values greater than or equal to 2 1/5 would make the statement true. Here I have negative 2 3/5. Again, the equals means that we darken the point there at the value, and it's going to be all the values less than negative 2 3/5. So there is the graph of the solution. Here is the solution statement right here, and there is the graph right there. All right.